Hello and welcome back to Physics for the 21st Century. My name is Greg Perugini, and this is topic number 30, simple pendulum. Now, we could make this pretty complex if we wanted to, taking into account large swings with damping and air friction and friction here. But if we don't swing it too far, maybe 10 degrees or 15 degrees tops, the equation melts down really nicely to something very simple as you see on the screen here. Notice that there's no mass in this. Mass doesn't matter. So on this swing, the complete circuit, if I pulled it back to here and then let it go, the complete circuit is one period, right? Right? So the time to complete one circuit, or a tick and a tock together, if we were thinking of this as a clock. So again, this is a very simple equation. Probably the easiest assessment you'll have in this class would be your last one, this one here. And let's just say that we're having this moving at a rate where it's doing 40 circuits or ticks and tocks per minute. Well, obviously it's 40 per minute, and there's 60 seconds for 1 minute, right? Actually, I wrote that wrong. Hold on, because you have to have 1 minute equals 60 seconds to get this to cancel, right? And so that leaves you with 0.667 seconds for your period. Okay? So if the length, let's say we're doing this on another planet entirely, this length is 1 meter. What is G on this planet? So we have that a period is equal to 2 pi square root of L over G. So clearly then period is 0.667. Length is 1. I'll do this in another color so you can see it better. You have only one variable left, G. So you take 0.667 and divide it by, use parentheses. Calculators sometimes mess up pulling this out. Parentheses 2 pi. Then take a square of both sides to get rid of the square root. And you will get, solving for this one leftover variable, actually it comes to 90.9 meters per second squared. This has a acceleration due to gravity, this particular planet, much, much greater, 10 times greater than our planet. We could also do an example where we talk about a clock. If we want a clock to have a period of 1 second on Earth, what should the length be? Well, again, very simple stuff here, right? Solving for the only variable we have left, length. Give yourself a second. You should be able to solve that, right? Length is 0.248 meters. Okay. So, in conclusion, keep in mind mass is not a factor. Remember the equation there. Remember your units. You might be getting something in minutes, lengths in centimeters. This equation needs the standard SI units. So this should be a fairly straightforward and fairly easy assessment for you. Very simple equation for the simple pendulum. And so that's it. And I'd also like to say thanks for taking the course. It's been fun. Hope to see you around campus. And I hope you were challenged.